So let me start off with the recording and then we'll start off with the session. Give me a second, please. Oh yeah, so recording has been started. I'll just share my screen once again. Okay, so is my screen visible, Niharika?
Yes, it is visible.
Okay, so hi everyone. My name is Akhil Pandey, and along with me is Niharika, and we, the team members of Team JarWiz, representing HERC, representing India and JarWiz on HERC platform, Human Exploration Rover Challenge, are presenting this webinar on this interesting topic, which is booming right now in the whole industry. It's 3D printing. So let's go ahead. Harika, would you like to take over? Yep. So
Yes, I would like to take over. 3D printing. For 3D printing, there are two methods. Absolutely everyone here, I think, must have heard about 3D printing. Saying about 3D printing is also known as additive manufacturing. There are two ways for 3D printing. One is additive manufacturing and another one is subtractive manufacturing. Additive manufacturing is considered better for 3D printing. So let's talk about what is additive manufacturing. 3D printing refers to a relatively new class of manufacturing methods which quickly produce physical prototypes. The one given on the left hand side, the image that you can see is a CAD model, and the image on the right hand side is the prototype of the same model which is given. Now, what you can understand from this is that from 3D modeling, we can construct and make a same model what we want to do. It appears exactly the same. Akhil, can you change the slide, please?
yeah.
Here are the two methods which I was talking about: additive and subtractive manufacturing. I think everyone is comfortable with Hindi and English both, so we can continue in Hindi. That would be a bit better. The image given lower, subtractive manufacturing. देखो एक आपको सर्कल बनाना है, एक बॉल बनानी है. What will you do? या तो एक सर्कल के ऊपर अलग अलग साइज के सर्कल्स रखते जाओ. वो एडिटिव मैन्युफैक्चरिंग होता है, ताकि तुम्हारा मटेरियल वेस्ट नहीं होगा. बट अगर तुम्हें सब्ट्रैक्टिव मैन्युफैक्चरिंग करनी है, मतलब तुम्हें उसी स्फीयर को बनाने के लिए उसमें से कुछ सब्ट्रैक्ट करना है. सो सब्ट्रैक्टिव मैन्युफैक्चरिंग में हम क्या करते हैं, हम एक क्यूब बनाते हैं एंड क्यूब के अंदर से हम उस स्फीयर को निकालते हैं. ऐसे एडिटिव मैन्युफैक्चरिंग की वजह से हमारा मटेरियल भी बच जाता है. इनफैक्ट जो भी मटेरियल इससे बचता है सब्ट्रैक्टिव मैन्युफैक्चरिंग से, वो फिर से रॉ मटेरियल में चला जाता है और उसको हम दोबारा से रीयूज कर लेते हैं. अब एडिटिव मैन्युफैक्चरिंग को ऊपर माना जाता है सब्ट्रैक्टिव मैन्युफैक्चरिंग से, क्योंकि मटेरियल कम लगेगा तो उसकी कॉस्ट कम होगी, वो उसकी स्पीड ज्यादा होगी, उसका मटेरियल जो बनेगा वो बेटर होगा, उसमें कॉम्प्लेक्सिटी नहीं होगी, तो हमें मटेरियल रिमूव नहीं करना पड़ेगा. तो 3D प्रिंटिंग में लेयर बाय लेयर एडिशन होगा. मतलब पहले ऐसे एक लेयर आएगी, उसके ऊपर दूसरी लेयर, उसके ऊपर तीसरी लेयर, लेयर ऑन लेयर तुम करते जाओगे. अखिल, कैन यू चेंज द स्लाइड? अब 3D प्रिंटिंग का प्रोसेस, तुम मतलब 3D प्रिंटिंग कहाँ से स्टार्ट करोगे और कहाँ पे एंड करोगे. पहला तुम्हारे माइंड में ना बेसिक आइडिया रहना चाहिए कि 3D प्रिंटिंग तुम्हें बनानी क्या है, मतलब क्या ऑब्जेक्ट तुम्हें बनाना है. सपोजिटली तुम्हें एक नॉर्मल पेन बनाना है, एक स्फेयर बनाना है, कुछ भी हो सकता है. यू कैन मेक एनी कॉम्प्लेक्स थिंग फ्रॉम अ 3D प्रिंटर एंड इवन द स्मॉलेस्ट एंड द बेसिक डिजाइन. सबसे पहले तुम कैड सॉफ्टवेयर में जाके तुम उसका मॉडल बनाओगे. उसके बाद तुम उस जो मॉडल होगा तुम उसको कन्वर्ट करोगे .stl फाइल में। .stl फाइल में कन्वर्ट करने के बाद तुम स्लाइसिंग सॉफ्टवेयर का यूज करोगे। और स्लाइसिंग सॉफ्टवेयर से क्या होता है, तुम ना उसकी लेयर्स डिफाइन करोगे कि लेयर्स कैसे होंगी। मतलब तुम्हें लेफ्ट टू राइट बनाना है, तुम्हें पहले आगे का बनाना है या फिर पीछे का। उसके बाद तुम्हें लेयर स्लाइसेस एंड टूल पाथ, पूरा तुम टूल पाथ दोगे उसका। फिर ये एएम प्रोसेस इज एडिटिव मैन्युफैक्चरिंग प्रोसेस। तुम्हें इसमें एडिटिव मैन्युफैक्चरिंग यूज करोगे एंड यू विल डू इज you will, like you have a paper, you need to design something. First you will create the base and then layer to layer you will create the object. Then you will have the 3D object with you. Okay, next slide please. From this on, my friend Akhil will continue.
Okay, so hi, welcome back. Yeah, so I'll take over on what 3D printing is considered as an additive manufacturing method. Firstly, let's simply discuss what is 3D printing. It is just printing in a 3 dimensions. Okay, so 3D printing is considered an additive manufacturing method, and meaning material is added until a specific shape is formed. As Niharika explained it really well, that we add we make an object layer by layer. We add material instead of taking a whole cube, as Niharika explained in the previous slide. Instead of taking a particular whole cube and dividing it and making a proper shape from that whole cube, there's a lot of wastage from it. So what we prefer here is additive manufacturing, that we use simply layers. We simply develop the whole object what we want by layer, okay. Depending on the level of accuracy required, the 3D printing is there are 3 different kinds of 3D printing processes available. First, we have the fusion deposition modeling, which is usually known as FDM. Then coming on to SLA method, which is which is an acronym for stereolithography. Okay, and then we have selective laser sintering, which is known as SLS. So these are the 3 basic technique. These are 3 basic processes that are covered under the 3D printing process. 3D printing. So I'll repeat again. It's FDM, which stands for fusion deposition modeling. Second is SLA, which is stereolithography, and third is the selective laser sintering. That is SLS. I'm sorry. So coming on to fusion deposition modeling, it is the most popular and affordable 3D printers available. They use thermoplastic filament, which is melted and extruded layer by layer. Yeah, as I'm saying it again and again, it is melted and extruded layer by layer. It's recommended to use them for first run prototypes or for home uses. Let us consider that we are working on a project and we are not sure if that is really going to work or not. So firstly, if we want to just try for a prototype, that we want a prototype of it, we just want to test it under certain conditions. So we make a prototype, and usually FDM method is used for FDM process is used in these type of applications. Fusion deposition modeling, FDM, is a technique for depositing hot plastic filaments in a specified pattern using the melt extrusion process. The FDM uses a print head that can move in both X as well as Y direction over a build platform. A platform is set over it, and it can go in both the directions. The polymer is then extruded through a heated nozzle and deposited as filaments in the CAD design. CAD design, as you know, like you firstly design a 3D model for it, as Niharika explained it earlier. Then when we are actually printing it, it's what the CAD design is finally processed. The scaffold is then completed by lowering the build platform and adding another layer. So simply just to summarize, FDM layer by layer add hota rehta hai, and FDM is simply fusion deposition modeling, as the word suggests. So it is the figure of FDM process that It is divided into various components. That is build material spool. That, as you can see, it's the material that we are using. Uh, we'll go on to it in the again as follows. Okay, and then support material we use. Then it's the build platform, which is taken as the rest area. Then we have the foam base over which our work piece is supported. Then part is taken and part supports are taken. Then we have various support material filament, as you see, and build material filaments and extrusion head, drive wheels that work on its processes, and liquefiers, and including the extrusion nozzles. Then coming on to SLA technique, that is the stereolithography. SLA 3D printers have a tank filled with liquid resin into which a platform slowly sinks and then rises while a UV light hardens each layer. Okay, so it is also a process, and then to harden when it's like risen up from the liquid surface, UV lights are reflected over it, and then due to these UV lights, it gets hardened. The process repeats until a 3D model is complete. It's not as cheap as FDM printing, but it is recommended for high resolution prototypes. If we consider we want to develop a simple, if you want to develop a simple cuboid, okay, so it's not a simple cuboid, but if you want to simply print this kind of shape, we usually prefer FDM process because it's cheap and easy to process. But if we want really complex, let me figure out what can print. Okay, so I hope you can see this mouse. If you want to like print this mouse, it needs really high accuracy and resolution. We'll prefer SLA process in this type of printing. Then, give me a second. Yeah, so it's the diagram of like SLA, the stereolithography. And as you can see, there's a liquid resin surface, and then the platform is dipped inside the liquid. And after the platform is risen up, there's a laser source that reflects the scanning, there's a scanning mirror too, which reflects the UV light over the reflected surface, and it just gets hardened. So this was the SLA method, and now coming on to the SLS, that is selective laser sintering. These 3D printers use powder which is sintered layer by layer with the help of laser until you get a solid model. Okay, it's a more specialized 3D printing method, and that's why it's recommended for high-end industrial prototypes. Unsurprisingly, it's more expensive than FDM and considered to SLA. So if we are working on under great really precise project, so we use SLS method because in the industries where we need high amount of prototype, if we need high manufacturing prototypes, so we use SLS techniques rather than FDM and SLA because it's highly resolution, and it has high resolution, and then but it is expensive too. And it's the diagram of the SLS. SLS. So you can see that there's a platform, and then counter rotating powder leveling roller is there, which is rolled over the surface. There's a powder bed and a laser beam, and also the scanning mirrors. Okay, so coming on to now additive manufacturing in metals. So this was 3D printing. Like usually we consider that 3D printing is used for plastic printing and like that, for different types of plastics and different types of material. But you don't usually talk about metal printing. Okay, so like talking about additive manufacturing metals, additive manufacturing technologies are exploding in popularity, as we know, on daily basis. Many people conceive of 3D printing as a thermoset of or thermoplastic process, but metal may also be 3D printed. The fact that constructing with the raw material rather than removing it or casting it in a mold makes 3D printing an additive process. Metal 3D printing prototype is more than a fad. It's a valuable new form of component manufacturing. It's a technique that allows for the creation of complicated geometries at previously unthinkable scales. It's also a technology that promises ultra lightweight components and systems that don't compromise on strength. When it comes to metal 3D printing, there are plethora of names or acronyms or abbreviations to choose from. It can easily get perplexed. Coming on to two types of processes that are covered under the additive manufacturing in metals. Firstly is the power fed systems, which are also referred to directed energy deposition, which I'll not like. These are the topics which I'll not be going to talk about because they will get way too complicated in just this brief session. And yeah, it's 8:32 already, and it will take a lot of time for explaining each and every process of it. So power fed systems and power bed systems. So a power fed systems are also known as directed energy depositions, uh, laser metal deposition, or laser cladding. If you ever heard of it, of these methods. This is a precision automated deposition system. The thickness ranges from zero point 0.1 millimeters to over a millimeter. Then coming on to power bed systems, which are also referred as DMLS. I guess you've heard of it. DMLS stands for direct metal laser sintering. Then coming on to SLM, it is also known as SLM, that stands for selective laser melting, also known as laser fusing and electron beam melting. So that it's just a figure of how metals can also be 3D printed. Okay, so just to brief, we usually prefer casting, like because it's easy process. I guess if any one of you have been in the first year, or like if we have juniors in here, you'll study in your further class in your college, that we usually prefer casting in your first year of engineering, particularly. We use casting of materials to metal, but we don't talk about additive manufacturing in metals. So additive manufacturing is a like method we can use, and it is really cost effective, and a less material is wasted in this additive manufacturing. Then coming on to metal prototyping. So can we have in a chat box know that Niharika, do we have chat box in here?
Yes,
Yeah,
we have.
we do have.
Let me know.
What are the advantage? Okay, I'll just take over the questions first. What are the advantages of laser fusing over FDM? Okay, so usually we consider FDM process for thermoplastic materials, but laser fusing is usually taken for considered considering metal prototype. Considering when we are manufacturing of metal, like metals, yeah. Then also, so yeah, I just wanted to confirm if everyone's here. Do we have any more questions? Any more doubts? Or should I go ahead? Okay, so no more doubts. I wanted to ask, can you write in chat box, what do you think of when you hear what a word prototype? Anyone? What comes to your mind when you hear a prototype of anything? So what comes to your mind? A model. Mirat says a model. Okay. A miniature version. Ashraf. Oh, okay. Any more? A miniature version. Okay. Yep, I didn't get in at the first time. It's miniature version. Okay. Any more? Anyone else? What comes to your mind when you hear the word prototype? Okay, so I don't think anyone. Guys, Acha, okay. So let's keep it a bit, I hope you all have watched Shark Tank. Okay. So in this first season of Shark Tank India, there were various, there were various, I just don't know what we call them. Okay, I'm sorry for that. There were various people who presented their prototype of their particular model. Okay, if of their process, yeah, working model, yeah. So working model where which you can test for before the actual manufacturing of material of manufacturing of your product. So my prototype is a thing that we usually test over, and we test for various under various conditions, and a test under various oh, Ashni reacted, thumbs up, great. Yeah. So yeah, prototype is something that you usually test for firstly before the actual manufacturing of of your model. Yeah. So I'll just continue ahead. Most prototypes are not built to provide any actual mechanical functionality. They might not even be a proper size of the object if it has micro or nano features. Instead, they could be for marketing, brainstorming, display at a conference booth, or Shark Tank, or some other reason. Yeah. Whether 3D printed or not, a metal prototype, considering metal prototype, a metal prototype will have better aesthetics, closer to life test results, more ease to move into mass production. It gives better mechanical or function, manufacturing challenges in a similar material. That how what manufacturing challenges can we get in a similar type of material, cost saving over plastic in certain applications. If end product is 3D printed in metal or cast, we could have a similar experience with plastic also. If we are doing some CNC work, CNC is, I'll not be covering CNC also, work on end product manufacture, we'll get a clearer picture of the final product by working in metal. Actually, when you metal prototype any product, it it is really it has closer to life test results as it is written. You get better aesthetics of it, and usually plastics are inexpensive, but you don't get a proper feel of your product. Okay. So metal plastics are only inexpensive due to their ability to gain complex shapes through molds or casts. Excuse me. That doesn't mean that raw material prices won't be high because of prototype construction material is plastic. Yeah. So coming on to advantages of it, I would like Niharika to take over from here.
Thank you, Akhil. For the advantages, let's go over. This is a prototype of a material, what we are going to consider. First, 3D printing does not require any mold. As Akhil mentioned about the casting. We being in the second year in college, we have done casting. We require a mold to do that. It is a mold made of metal, and we have placed sand in it, and then the piece that we have to consider create. In 3D modeling, what we do is we create a CAD software, a CAD file, convert it into STL, and then we place it on the workbench, and then what we want to create is constructed on it using the layer by layer process. Okay, next slide. Multiple parts can be produced in one cycle. मतलब जैसे जितना बड़ा तुम्हारा वर्क बेंच है, जितनी बड़ी भी तुम्हारी कैड फाइल हो, उससे कोई फर्क नहीं पड़ेगा. वर्क बेंच पे तुम्हारे कितने पीसेस आ सकते हैं, तुम उतने पीसेस एक बार में डिजाइन कर सकते हो. बट अगर तुम्हें कास्टिंग से डिजाइन करना है, तुम्हें मशीनिंग से डिजाइन करना है, तो तुम्हें उसमें और ज्यादा टाइम लगेगा, तुम्हें उसमें और ज्यादा मशीन्स चाहिए. बट ये टाइम सेविंग है. तुम्हें मतलब तुम ना, अगर तुम्हें लाइक नट बोल्ट्स डिजाइन करने हैं, A workbench is very big. I mean, like around 3 foot in length, and you can design a lot many. I can't even count that. Next slide, Akhil. 3D printing has been used recently to make parts of various sizes. 3D printing requires a file, so you can construct even a big tumbler. What we right now is seeing, we can construct a rocket from 3D printing. I don't know you have ever heard about it or not. I was shocked when I heard about it. That we first started designing a screw, then we had gone too far that we can create a rocket, and वो rocket अब like next year that is going to be launched. So depending on the sizes, you can create whatever you want to create depending on the size of the workbench. Okay, next slide please. Geometry complexity is not a limitation in 3D printing. अब ये तो ऑब्वियस है, जियोमेट्री कॉम्प्लेक्सिटी तो तुम कितनी मर्जी कर लो, जैसी तुम कैड फाइल उसको दोगे बस उसे तो वैसे का वैसा डिजाइन करना है. इट्स लाइक अ रोबोट जो तुम्हारे सारे काम कर रहा है, उसे कोई फर्क नहीं पड़ता तुमने एक सिंपल सा क्यूब डिजाइन करने को दिया है, एक स्टार दिया है, कुछ भी हो, इट डजंट केयर अबाउट दैट. ओके, नेक्स्ट स्लाइड. Jewelry design. These all are the jewelry designs which are made till now from the 3D modeling. Even after that, you can design what you want. मतलब मैं तुम्हें ना अपना एक्सपीरियंस शेयर करती हूँ. फर्स्ट टाइम जब हमने 3D प्रिंटिंग स्टार्ट करी थी, हम लोगों ने ना, हमें बीइंग मतलब मेरे पास स्पेशलाइजेशन है तो हमारा वेबिनार हुआ, हमें सिखाया गया, हम लोगों ने डिजाइन करा था एक स्क्रू. दैट वाज लाइक अ 1 इंच और 2 इंच समथिंग, बट उसको डिजाइन करने में, उसकी कैड फाइल बना के उसको जो मतलब जब हमारे हाथ में वो पीस आया, वो सेटिस्फैक्शन एंड कि हमने ये किया है, बीइंग अ इंजीनियर ये बहुत बड़ी चीज होती है. तो ज्वेलरी डिजाइन तुम लोग जो चाहो वो डिजाइन कर सकते हो, नॉट इवन ज्वेलरी. ओके, नेक्स्ट स्लाइड प्लीज. वेट रिडक्शन मतलब मटेरियल तुम्हारे पास अगर कम लगेगा तो ऑब्वियसली उसका वेट कम होगा, वेट कम होगा तो कॉस्ट भी कम लगेगी. अब इस इमेज में तुम्हें एक स्टील बकल दिया है लेफ्ट साइड में और दूसरी साइड में एक टाइटेनियम का बकल है. टाइटेनियम इज एक्चुअली वे मोर लेस इन वेट देन अ स्टील बकल. अब इस टाइटेनियम वाले बकल में तुम्हें बीच में स्पेसेस हैं, जहां जहां पे मटेरियल रिक्वायर्ड है सिर्फ वहीं पर मटेरियल लगाया गया है. बट इस स्टील बकल में तुम्हें ये कन्वेंशनल मोड से डिजाइन है, ट्रेडिशनल मोड से, तो तुम्हें इसे बस डिजाइन किया है, तुम इसमें कुछ ऑल्टरेशंस नहीं कर सकते, ये तुम्हारे पास ऑप्शन नहीं है. बट 3D मॉडलिंग में तुम जो चाहो वो कर सकते हो. मतलब इफ आई कंसिडर 3D मॉडलिंग, ये फ्यूचर है आने वाला. हमें छोटी छोटी चीज जो भी हमें चाहिए वो सब 3D मॉडलिंग से बनेगा. ओके, नेक्स्ट स्लाइड. प्रोज एंड कॉन्स. जैसे कि बताया, पहले तो डिजाइन तुम जो चाहो वो बन जाएगा. डिजाइन की मतलब कोई लिमिट नहीं है, कोई लिमिट. तुम जितना ज्यादा अमाउंट में बनाना चाहोगे उतने ज्यादा अमाउंट में बन जाएगा. तुम्हें टूल्स कम चाहिए, इवन टूल्स कम क्या, तुम्हें सिर्फ एक मशीन चाहिए दैट विल डिजाइन फॉर यू. ग्रीन मैन्युफैक्चरिंग, कुछ वेस्ट नहीं होता. एनर्जी एफिशिएंट. एनर्जी एफिशिएंट ये है क्योंकि मतलब तुम्हें बड़ी मशीन्स नहीं चलानी पड़ेगी, छोटी सी मशीन है, तुम्हें बड़ी बड़ी फैक्ट्रीज में नहीं जाना पड़ेगा. पर्सनलाइज मैन्युफैक्चरिंग, जो तुम अपने लिए चाहो वो तुम सब बना सकते हो. कॉन्स, अनएक्सपेक्टेड प्री एंड पोस्ट प्रोसेसिंग रिक्वायरमेंट्स. मतलब क्या होता है, जैसे तुम ना एक 3D मॉडल अगर बना रहे हो तो तुम्हें वर्क बेंच के ऊपर ना कई बार क्या होता है, वो ना सपोर्ट नहीं करता, तो तुम्हें उसके लिए एक नीचे अलग से बनाना पड़ता है एक रेक्टेंगल, सो दैट कि वो उस पर सपोर्ट कर सके. मटेरियल इसका महंगा होता है तो इसकी कॉस्ट बढ़ जाती है. इंडस्ट्रीज में लोग आजकल इसे यूज करते हैं, इसकी स्पीड बहुत ज्यादा स्लो होती है. लाइक अगर तुम्हें एक छोटी सी चीज बनानी है, इट विल take like 4 hours to construct that. इनकंसिस्टेंट मटेरियल, तुम मटेरियल तो कोई भी यूज कर सकते हो, बट हर एक मशीन हर मटेरियल के लिए वर्क नहीं करती, तुम्हें उसके लिए स्पेसिफिक चीजें चाहिए होती हैं। ये लिमिटेड नंबर ऑफ मटेरियल्स के लिए वर्क करेगी। ऐसा नहीं है कि तुम कोई भी मटेरियल डाल दोगे और वो वर्क कर जाएगी। ओके, नेक्स्ट स्लाइड प्लीज। मटेरियल ऑप्शंस। अब तुम एक अगर 3D मशीन में मटेरियल डालोगे तो तुम क्या क्या यूज कर सकते हो। अगर मेटल है तो प्लेन कार्बन स्टील, टूल स्टील, स्टेनलेस स्टील, एल्यूमिनियम, कॉपर, टाइटेनियम, ब्रोंज। मतलब इसके अलावा भी बहुत सारे मटेरियल होते हैं जो तुम लोग यूज कर सकते हो। पॉलीमर्स में एबीएस, नायलॉन, पॉलीकार्बोनेट, पीपी, पॉलीस्टाइरीन, पॉलिएस्टर, ग्लास फिल्ड पॉलीएमाइड्स, others like sand, ceramic, elastomers, tungsten, wax, plaster, starch। मतलब अगर मैं बोलूँ ना तो मटेरियल ऑप्शन में अगर तुम सैंड के बारे में सुनोगे, कैन यू बिलीव सैंड से भी तुम कुछ बना रहे हो। मतलब जैसे मिट्टी के घड़े बनते थे, तुम ना वैसी चीजें तुम 3D प्रिंटिंग से बना सकते हो। दैट्स ऑल व्हाट वी वांट टू शेयर अबाउट दिस 3D प्रिंटिंग। अभी भी मतलब किसी को कोई डाउट है, कोई कुछ जानना चाहता है 3D प्रिंटिंग के बारे में, हमारे एक्सपीरियंसेस के बारे में, यू कैन आस्क दैट।
Okay, so like we'll get that to the chat box, and so before like summing it up, I want to give a brief of all the slides we had, and let's start from the starting itself. Like what is starting off with 3D printing? That what 3D printing is. 3D printing कुछ नहीं है. 3D printing is just printing in 3 dimensions. Okay, simply when you go to a cyber cafe, when you yourself print, it's just a sheet you put into the printer and it comes out. It's just a 2D figure that you get printed. But 3D printing is, as the word suggests, printing in 3 dimensions. Two types of 3D printing. There are 2 types of manufacturing methods. Firstly is the subtractive manufacturing. Second is the additive manufacturing. Additive manufacturing is what we consider 3D printing.
Akhil, can you wait? There is a question in the chat box. What about the machine name? Actually, what Akhil mentioned earlier about the FDM machine, the fused filament fabrication, that is a machine that we use for 3D printing. In that, we insert the element what we want to construct, and we connect the computer or a laptop with it so that we can have the CAD file in that. Akhil, you can continue.
Thank you so much, Niharika. Yeah, so coming on to this slide of it, additive manufacturing is, manufacturing anything from with just the precision of it and how much we want to, produce by a process of layering. We do it by layer instead of subtractive manufacturing. As the name suggests, subtractive manufacturing is you take a complete model of take a complete material, and then using various post processes, cut down to a proper desired shape what you want. And that subtractive manufacturing, there's a lot of wastage of material, and hence we consider additive manufacturing as like a future, as even Elon Musk suggests that additive manufacturing or 3D printing is the future. Yeah. So process of 3D printing, you firstly take a 3D CAD model, you design it over various CAD softwares. You have AutoCAD, you have SolidWorks for it, you have various other softwares for designing. Then you take you need a proper file format. That's the STL file format you need for the 3D printing. Then through slicing software and finally through additive manufacturing process, you get a 3D object. Then we have 3 types of 3D printing processes. That is FDM, fusion deposition modeling. Second is the SLA, that is stereolithography. And third is the SLS, that is selective laser sintering. Yeah, FDM process, I've explained it. SLA, I've explained it. SLS, I've explained it. Coming on to additive manufacturing metals. Additive manufacturing can also be done used in metals also. It's not just restricted to plastic or thermoplastic. materials. There are two types of processes involved in additive manufacturing in metals. First is the power fed systems, which is also known as directed energy deposition, laser metal deposition, laser cladding. And then we have power bed systems, which are also known as DMLS, that is metal laser sintering, SLM, selective laser melting, laser fusing, and electron beam melting. Then metal prototype, we usually prefer metal prototype instead of plastic prototypes because metal prototypes has better aesthetics, closer to life test results, more ease to move in mass production, and uh, we have further on. Then coming on to advantages, 3D printing does not require any mold or precursor to manufacture. Multiple parts can be produced in one cycle. 3D printing has been recently used in various to make various parts of various sizes. That from a screw nut to a rocket, as Niharika said, already gave you a brief of it. Then geometric complexity is not a limitation in 3D printing. It's yeah, it has already been explained. I'll just give a brief of it. Then jewelry design you can design. Then weight reduction, and finally the pros and cons. And we have read about the material options we have. These are just the limited material options we have just presented. We have a lot more options in these components, also in these further types. So thank you so much. And now, are there any more questions? Like, let's say questions now, Niharika. Okay. So there's a question by Aditya Nath Yogi that what are the disadvantages of 3D modeling over 2D modeling? Disadvantages of 3D modeling have already been explained, as Niharika did, that you don't have, there are technical issues that you can get anytime, anywhere, software issues, and you also need, sometimes you need post processes that can be done over a 3D printed model. Post processes include, like giving it a proper finishing. Because there are sometimes you don't get proper finishing of your material, so you need post processes also. So this is also these are the advantages of 3D modeling over a 2D modeling. What about machine name has already been taken? I want to know about machine name, which is the best software for 3D modeling. There is not a particular software which is best for 3D printing, but it's
There are
just the
various softwares which we can use, like Autodesk and Cinema 4D, Maya, ZBrush. Whatever you want to use, you can do that. There are various 3D printed file formats rather than STL what we use, like OBJ, PLY. You can convert it in any form, whatever you wish to.
Yeah, so there's not a particular answer for this, which is the best software. We are not marketing for any, software company right here. Where to learn 3D modeling? Can you all do a webinar for the same as well? Actually, we are restricted to it, but surely we'll come ahead with it. And in JarWiz, with Team JarWiz, you can get anything. You can learn anything here, and we'll keep carrying out this webinar series, and surely we'll take it into consideration. How much did they cost? Considering 3D printing, as I said that usually SLA is the most expensive of all these processes, but 3D printing, when you consider subtractive manufacturing, additive manufacturing is a bit expensive considering it. Yep.
Actually, Sanchi, if you want to purchase like a 3D printer or you want to do a 3D printing, that depends on the cost. As for the 3D printer, it can, in India, it can cost up to 2 lakhs and even more than that. What you want to print, it depends on that. And for 3D printer, if someone has a 3D printer, you can just go and print it in like a few thousands. 2000, 3000, depending on the material what do you
Material,
want.
or you know, your model also, it depends on it.
Yes.
Nice question, Sanchi Pandey. Then coming on to Adityanath Yogi, is human cloning and 3D printing same thing? I won't say that these are same thing, human cloning and 3D printing, but that they aren't same. Yeah, that's all. Uh, we have Wangchuk Lau, that nice webinar. Thank you so much. Nice website. Taking so much of time in 3D printing is software issue or machine issue? Taking actually, Miraj, there are various uh, errors that can occur anytime. There can be a software issue while considering the software, because there are technicalities considering both software as well as machine. So yeah, we'll be taking up the quiz. And yeah, these issue, how much usually it takes less time in 3D printing, but a technical issue can arise anywhere. So now, do we have host in here, Madhav
Yeah,
or
so
Tunika?
thank you for the wonderful webinar, both of you, Niharika and Akhil. This was a really informative session, and we hope everyone else found it like that too. So I'm just sending the link to the quiz, and we'll be starting in another 2 minutes at exactly 9 o'clock. Everyone can join the quiz by then, and I'll just like to remind you all that the top three participants will be getting the certificate of appreciation and achievement, as well as certificate of participation in the quiz. So all the best to you all, and here is the link to the quiz.
Go ahead, people, kill it.
Also, just a friendly reminder, even after the webinar ends, if you have any questions or queries regarding the topic or anything related to the STEM, you can visit our website anytime and type out your doubts and questions in the chat box on the website. We will get back to you soon, as soon as possible. And yeah, if you want to learn more about anything in like science and STEM, so just reach out to us and we will be glad to help you out.
Buckle up, guys. You know it all. Come on.
Congratulations, Suraj, Ananya, and Ashraf. You have scored the top 3 positions and you will be getting the certificate shortly. Please drop your email ID in the chat box. And for rest of you, very well tried. And thank you for joining us tonight. And we hope this was an informative session for you all. Feel free to leave any comments and suggestions you have on our website and in the chat box. And have a great night. And thanks a lot. That was it from our side. And yeah, Suraj, Ananya, and Ashraf, please send your email ID in the chat box. Thanks a lot, guys. Good night. Have a great day.